Okay, you guys complained about my tapping last time, so we're going to do things a little bit differently. Today we're looking at parallel and perpendicular lines. Parallel lines are lines that never intersect. That's the definition of lines that are parallel. When I'm looking at them algebraically, when I'm looking at y equals versions, parallel lines are lines that have the same slope. Lines that have equal slopes. Y equals 2x plus 7, y equals 2x minus 8. They'd have a constant slope, but the different y-intercepts would keep those lines parallel, never touching. And then we have perpendicular lines. Perpendicular lines intersect at a 90-degree angle. When I'm looking algebraically, they have negative reciprocal just mean the opposite slopes. So if I'm looking at y equals 5/2 x, the negative reciprocal of that would be y equals negative, then I flip that fraction 2 over 5x. They need to be negative, so one's going to be positive, one's going to be negative. They need to be reciprocal, which is just flipped. So that's what we're going to try right here. Negative reciprocals are flipped fractions with opposite signs. So when I look at 3/4, I'm going to flip it. So 3/4, I'm going to turn into 4/3. If this one is positive, this one needs to be negative. If I have a fraction, I'm going to flip it, 8 over 7. This one is negative, so this one needs to be positive. This is why we talked about it is huge to take those fractions, or to take those slopes, and put them over 1. Think about a zero slope. A zero slope goes like this. So you're going to have to think about what the opposite of that would be. What would create a line? It looks like this. I'll give you a hint. It's not a number. I want you to finish out 2, 4, 5. Once you are done, come back to the video and we'll talk about giving ordered pairs. So when I'm given ordered pairs, let me see if I can slide this paper a little bit without dropping my iPad. There we go. When I'm given ordered pairs, I'm going to set up 2 fractions. I want to do one for A and B. I want to do one for C and D. And I'm going to do that slope formula. And in case you forget, that slope formula is y2 minus y1 over x2 minus x1. So when I'm looking at AB, my y2 number is 6 minus my y1 number, which is 3, over my x2 number, which is 2, minus my x1 number, which is negative 2. Negative minus, I'm sorry, a number minus a negative is really saying plus. So 6 minus 3 is 3. 2 plus 2 is 4. I'm going to look at CD and I'm going to do the same thing. I'm going to set up my fraction bar. I have y2, which is 3, minus y1, which is 0, over x2, which is 3, minus x1, which is negative 1. 3 minus 0 is 3. 3 minus a negative 1 is really saying plus 1. 3 plus 1 is 4. Because my slopes are equal, that's an ugly line, they are parallel. On here, on 1 through number 8, you are telling me if they are parallel, if they are perpendicular, or if they are neither. It's possible for lines not to be parallel or perpendicular, to intersect at a different angle. Tell me, do the slope. I should see 2 fractions. Your fraction, setting it up with the slope formula, and your answer. Do not just tell me this. AB is 3/4. Don't do that math in your head. I want to see your fractions because that's where I mess up. Pause the video, go through number 8. Once you finish number 8, resume the video, and we'll talk about the back when you are given an equation. Oh, am I going to lose the iPad? Nope, saved it. When I'm looking at equations, the slope of this one is 7. The slope of this one is 7. So those lines are parallel. For the most part, equations tend to be the easiest ones. The issue is that sometimes they give me formulas where 1 is in y-intercept, m equals -1/5. This one is in standard form, so I have to go through and do the math. I need to turn it into slope-intercept form. -y equals -5x plus 4. Divide by -1. Y equals 5x minus 4. My m right here is a +5. My fractions are flipped because that would be 5/1. 1 is positive, 1 is negative. So these 2 lines are perpendicular. I'm going to turn you loose, let you work on this. I'll be walking around while you're working. Let's get busy.